Right.
It's hard when you're going back to back sometimes, getting somebody
Yeah.
out of here in time. So, all right. So what do we got going tonight? I haven't seen your other student today, so you're going to be giving me the new material.
We're just doing test reviews, so right now we're gonna do like inversely proportional and things like that.
Okay. You want to verbalize them to me, or you want to send them to me?
I'm sending them to you now.
Okay. You sent quite a bit to me last time. I might have some of them already. No. Now see, it tells me do I want to shut down my webcam, and I don't have my webcam on. Ooh, this a PD, oh no, good. That's right, I was concerned about that yesterday. I'm not sure, but I think when people send me a PDF file, it might cause my system to crash. I don't know. Is this the only thing you're going to send me, or you got more to follow?
I have a couple more that I'm gonna send a little later once we finish this.
Okay, let me close out that just so that I'll have room to do everything here. All right. As we started to talk about last night, the key to these problems is to always set it up, and the first thing you want to do is solve for K. So you have to set it up originally as a general equation with K in there.
Okay.
So which one are we going to start on?
Let's start on number 3.
Okay. So tell me how to write the general equation. W is inversely proportional to the square of V.
It'd be W equals K divided by V.
Divided by the square of V.
Yeah.
That's important because you can have that. Okay, so now they give us 2 of the 3 variables. They give us a W is 3 when V is 6. You can see that that's going to allow us to solve for K. So let's do that.
Okay, W3 equals K divided by 36.
Okay, so what is K equal to?
K is equal to 108.
Okay, so now what is my specific formula for this problem?
It's going to be, well, it's going to be W equals 108 divided by V squared.
Exactly. Now they give us 2 new, so find W when V equals 3.
So it's going to be W equals 108 divided by 9, which equals...
And that's what we're going to do on every single one of these problems. Is we're going to start out by writing the general equation, then we're going to solve for K, then we're going to use that K and write the specific equation.
Okay.
Okay?
Let's just go all the way down to 10, doing every single one.
Okay. So 4. P varies inversely as the square root of Q. It's my general equation.
Is that?
Well, inversely means we're going to have a K over something.
So that's going to be P equals K divided by the square root of Q.
Uh-huh. And now they give you a P and a Q, which will allow us to solve for K. And then we'll do the same thing. So what's the next line I should write?
12 equals k divided by 6.
My specific equation is what?
P equals 72 divided by square root of q.
So that, what is P when Q is 16?
P equals 72 divided by 4, which is 18.
Next one. Z is jointly proportional to X and Y. So how can I write that?
That one is going to be Z equals K times X times Y.
Uh-huh. Okay. Now they give us a Z, an X, and a Y. Although I can't read the Y, you're going to tell me what it is. It looks like it might be 3.
Yeah, Y equals 3.
Okay. So what's the next line I'm going to write?
18 equals K times 0.4, and then times 3.
Okay. Solve for K.
18 equals 1.2k, and then divide, and you get 15 equals k.
And the specific equation?
Z equals 15 times x times y.
And the answer?
Be Z equals 15 times 1.2 times 2.
30 times 1.2, which is...
Z equals 36.
Okay. So the only real tough part of these is writing the first general equation.
Yeah, that's what I have the most trouble with these.
Okay. So let's do 6. Just do it one at a time.
6. 6 is going to be W equals K times U times V.
Okay. Now, shall we just have you give the general formula for each of these, or you want to solve them all the way through for each one?
I'll just solve them all the way through.
Okay. So what's the next line I can write here?
24 equals K times 0.8 times 5. And then 24 equals 4K, and then K equals 6. And then you plug that back into W equals 6 times U times V. And then you get 18 equals 6 times...
So this is a little different.
6 times U times 2. So you get 18 equals 12U, and then U equals 3 over 2.
Right. Okay, so they do get a little different as we go down. Let's look at 7.
S varies directly as R and inversely as T. Would this one be S equals K times R divided by T?
Uh-huh.
Okay. Okay, and then it'd be 10 equals K times 5 divided by 3. So I'll multiply everything by 3. You get 30 equals... You get 6 equals K.
Okay.
and then you get S equals 6 times R divided by T, and then you get 3 equals 6 times 4 divided by T. So then with this, you multiply everything by T, so then it becomes 3T equals 24, and then divide by 3, T equals 8.
Yeah. You can't read. Yeah, you're going to have to read that character for me. What does that say?
It's supposed that R varies directly as P and inversely as Q squared.
Okay.
So that one is R equals K times P divided by Q squared, right?
Uh-huh.
Alright, so get 27 equals K times 3 divided by 4. So multiply everything by 4. You get 108 equals 3K.
Well, this one doesn't come out to be nice and even.
Yep, it's 36.
Oh, what am I thinking? Yeah, I was trying to do it in my head.
So then R equals 36 times P divided by Q squared. And then find R when P equals 2 and Q equals 3. So it'll be R equals 36 times 2 divided by 3.
That goes in there, 12, so that's 24.
R equals 24, yeah.
Okay.
Number 9, suppose that Z varies jointly as U and V and inversely as W. So this one be Z equals K times U times V divided by W.
Yeah, notice the K is always in the numerator, regardless of whether it varies directly or inversely. So there's no problem ever figuring out where the K goes. And the others, once you get the hang of it, you got it down.
Yeah, I'm starting. Yeah, at first, I had absolutely no idea where any of these went.
Okay.
So this one is Z equals K times U times V divided by W. So that turns into 0.8 equals K times 8 times 6 divided by 5. So then you get 4 equals 48K. Divide everything by 48, and then you get 1/12.
Okay.
Then you get Z equals 1/12 times U times V divided by W. And then
Now
find Z
notice,
to be...
I can put that 12 in the denominator if I want, but not the 1/12 in the denominator. The safest way to do this is to write it exactly as I wrote it, so that there's no confusion as to where that 1/12 goes. That happens to be the same as but don't get confused that I all of a sudden put K in the denominator. I didn't. K is 1/12.
Okay.
Okay? So now the rest of it is find Z when U is 3, V is, what is that, 10?
Yeah, V's 10.
And W is 5. 30 divided by 60 is 1/2.
Alright, number 10. W varies directly as Z squared and inversely as XY. So that'd be W equals K times z squared divided by xy.
Uh-huh. And you're going to fill in that for me. W is what?
W is 10, x is 15, y is 2, and z is 5. So 10 equals k times 25 divided by 30.
Right.
Alright, so multiply everything by 30, you get 300 equals 25k. Then you get 12 equals k.
Okay.
W equals 12 times z squared divided by xy. Find z. So W is 2, x is 8, and y is 27. So that's 216 at the bottom on the denominator.
How'd you know
So
that so
multiply
fast?
everything by 216.
Hold on. How'd you know that so fast?
Calculator.
Oh, okay. I was thinking you've picked up some magic in doing arithmetic here.
I wish.
So z squared is equal to what?
432 equals 12 times z squared. You can move the 12. Yeah, you can divide by 12. Then you get 36 from that equals z squared. Take the square root of both sides, and then you get z equals plus or minus 6.
Very good. Need another page?
Yes, I will.
This is direct. Oops. And inverse proportion. I like to label my files so I know what subject matter they are.
Alright, I just sent it.
Wow. How many files attached? One or two?
It's just one. I don't know why it's taking so long. I'm going to make sure it's 7.
Yeah. Why don't you read the first one to me while we're waiting for that to get to me?
Alright, the first one is the frequency of a radio signal varies inversely as the wavelength. So
Frequency is equal to what?
frequency C is 1200 kilohertz.
No,
KHZ.
what's the general formula? That
Oh,
frequency varies in whatever.
it'd be frequency equals K times wavelength. Or
Inversely.
they're divided by.
It was inverse, wasn't it?
Yeah.
Okay. So, in other words, these are the same problems. They're just worded as word problems instead of as the previous 10 were.
Yeah.
Okay, so what's the rest of this?
So should we just make frequency F and wavelength W?
Sure. Which is what I've done.
Alright. Yeah, it's sent, so check your email and see if it's there.
Yeah, it is. I didn't see that file. Come onto my computer. What happened to it? Huh. Hold on. Wonder. Alright, there it is. Okay, so what's the rest of it that I can write?
So then you get be 1200 equals K times, or K divided by 250. Then you get 300,000 equals K.
Okay.
So then you go back, F equals 300K divided by W. And then you have, what frequency has a signal of wavelength 400 meters? So F equals 300,000 divided by 400, which is 750.
Okay.
All right.
General?
Yeah, all right. So number 2, the OHM's law, the current flowing.
Oh, by Ohm's law. Okay. So what's the general formula?
Inversely proportional, so that'd be the same as,
So give me an equation.
it'd be, should we just make,
That's what I do with all of these, is whatever it says, that's the variable I use.
okay, so let's just do C equals K divided by resistance of the wire, which would be R, yeah.
Okay.
And then the next line, the current is 5 amps, so it'd be 5 equals K divided by, is it 24?
Huh?
120 equals K. And you get C equals 120 divided by R. You get 8 equals 120 divided by R. Multiply it by R, 8R equals 120. R equals 15.
Boring. All right, the next one.
Number 3, the heat loss through a glass window varies jointly. Would this one be, we'll just do heat loss is H and the window is W.
No, I called it HL as heat loss. In other words, we can just call it heat, H. So the heat, H is heat loss. Varies jointly as the area of the window and the difference between the inside and outside temperatures. So all of a sudden, not boring. So how can I write that? You know, we need a K, right?
Yeah.
We always start out by writing K. It's going to go in the numerator regardless. Now, if I said it varied jointly with A and B, what would I write here?
You would write K times those other two variables.
Okay, so one of the variables is the area of the window. What's the other variable?
The other one would be temperature.
The difference between the inside and outside temperature. Just like that.
Okay.
Okay. If the heat loss through a window with area of 3 is, so what's the next part?
It'd be 720 equals K times K times 3 times 15. So you get 720 equals 45K, and then K equals 16. Alright, so H equals 16 times A times and then
Now I write that as two variables because they may not give you the difference. They may give you the temperature outside and the temperature inside.
yeah. So for this one, the next step we're finding H, so 16 times 4.5 times 12. $864.
Okay. Number 4.
Alright, so let's just do one variable C. We could do another one as D for diameter,
Okay.
and then L for
I
length.
would suggest always starting with K.
Okay.
Now what's the rest of it?
C equals K times D divided by L.
It's the square of the wire's diameter.
Oh, so K times D squared divided by L.
Yes.
Alright, so 50 meters of wire with diameter 2 millimeters. So it'd be 0.12 equals K times 4. There's
Divided by what? What's the length?
oh, 50. Sorry, I completely missed that.
Okay.
So you get, on the other side, once you multiply by 50, you get 6 equals K times 4. So K equals 6, 2, or 3 over 2.
Okay.
So then it's C equals 3 over 2 times D squared divided by L. If y is the same as length is 75. So it's going to be C equals 3 halves times what is 2.5. You get C equals 3 halves times 6.25 divided by 150. So then you get 150 C equals.
You don't really need to do that. In other words, there's no reason to multiply by that. Just come up directly with what that number is.
Oh yeah, that's right. So it would be I got 0.0625.
Okay, so let's check and see if that is in the ballpark. Well, 6 divided by 75 is less than 10. Still doesn't look right to me. Do that multiplication again. 3 times 6.25 divided by 150.
No, it's 3 halves.
Well, but notice how I wrote it.
Oh yeah. Oh yeah, I see that. Wait, wouldn't it be? Oh wait, I did something wrong actually. I divided by the wrong thing. So I wrote 150 and it was supposed to be 75. So that's what it is. Let's redo this.
So I'm guessing it should be a little bit more than a tenth.
Yeah. Yeah, it's 0.125.
Okay. That ballpark check is critical. You can save an awful lot of math errors by doing a ballpark check.
Okay.
It's not always easy to do, but it's helpful for problems just like this. All right.
Okay.
You better not miss a single problem on proportionality.
I won't.
If you do, it'll strictly be accidental.
Problem. Alright. I have another thing.
Are we doing 5, or are we going to go to a different subject here?
No, we're just going to go to a different thing.
All right. Close this page out. You sending me another thing, or is it something you can verbalize?
Yeah, I'm sending you another thing. Actually, can you pull that? Can we actually do 5? Is that alright?
Can we actually do 5? Is that alright?
Sure.
Alright, sorry about that.
Alright, sorry about that.
It's all right.
Five and 6 directly for. Oh wait, you don't have 6. So
I don't have 6, but I can do 5.
A light meter 7.
So just start with from left to right as it reads.
So it's inversely proportional. So that means it'd be L equals K divided by.
Or I used I for the intensity of light.
Oh yeah. So I equals K divided by whatever we're going to use for that variable. So let's do...
Well, what is the denominator here? Use D for distance.
Okay.
So it's I equal K over what?
D.
No, it's the square of D.
Or squared. Yeah.
Okay? And a lot of things that vary inversely vary with the square, not, it's like gravity and all kinds of stuff. So when you're doing inverse, remember that there's a real good chance it could be squared.
Okay.
Okay, so
Alright.
7.5 works with, let's see, a light meter 7.5 meters from the source registers 24 lux. So what can I write?
So that 24 lux would be the intensity, so it would be 24 equals K divided by 7.5 squared is 56.25. And then the final answer is 1,350 for K. So then you get I equals 1350 divided by D squared. What intensity? So I equals 1350 divided by 225. Which is, so the intensity is 6. Alright, so number 6 I'll just verbalize to you because these relate to each other. It's a light hangs 4.8 feet above the center of a circular table, 7.2 feet in diameter.
One moment. Let me go back and write my, this is the specific equation, right?
Yeah.
Okay. Say again, I wasn't listening.
It's a light hangs 4.8 feet above the center of a circular table, 7.2 feet in diameter. If the illumination is 25 lux at the center of the table, what is it at the edge of the table?
Let me think about this in a moment.
I can send it to you if you want.
No, I don't need to.
Okay.
If the illumination equals what?
25 lux at the center of the table, what is it at the edge of the table?
So first of all, is that true? Squared. Right? In other words, that should be the center of the table. Make sure that that's true. Just so I understand the problem properly.
Alright, divided by...
Yeah, that is going to be true.
I got 58.59. When I solved that side of the equation.
So, read the whole problem again.
A light hangs 4.8 feet above the center of a circular table, 7.2 feet in diameter.
Okay.
If the illumination is 25 lux at the center of the table, what is it at the edge of the table?
So apparently we're not using the same equation that we just figured out.
The direction says in problems 5 and 6, use the fact that the intensity of light measured in lux is inversely proportional to the square of the distance between the light source and the object illuminated.
Okay, so shouldn't the illumination at the center of the table be 1350 divided by 4.8 squared?
Is 1350, would that be the right K for
Well,
this as well?
maybe not. No, I'm thinking that this must have a different K.
Yeah,
So
I
let's
think it
put the
might.
K there. Okay. And what'd you get for K when you solved this? Oh, you
It was
didn't
like,
solve it, but go ahead and solve
yeah, I
this
didn't
for
solve.
K.
Okay.
That's why this is confusing. It's not the same K for problems 5 and 6.
I got 576 equals K.
Okay, so now I have I equals 576 over D squared. What is the distance to the edge of that table?
Three, no, 3.6.
Well, that's the radius. In other words, we have a triangle that is 4.8 on this side, 3.6 on this side.
You'd have to use Pythagoras. What did you have to use Pythagorean to?
Yeah, go ahead and do that.
Alright.
Only don't take the square root of it. Leave it as a radical because we're going to have to square it to solve this thing. So there's no point in taking the square root of it when you solve for it. See what I'm
I
saying?
got 36, so it would be H equals 6.
Really? H equals 6?
Yeah. It's A squared plus B squared equals C squared, correct?
Right.
Yeah, that's what I
So
did.
C squared equals 36, so H equals 6.
Mm-hmm.
Okay. So now the intensity is going to be what?
It is 25 flux at the center of the table. What is it at the edge of the table?
Right.
So
we figured out K based on the first piece of information. Now we have a new illumination at the edge of the table. It's not 25 lux because the distance has changed. The distance
is it going to be I equals 576 divided by 36?
Yes.
So that's I equals 16.
That's quite a difference.
Yeah.
25 lux in the middle of the table, 16 lux at the edge of the table. No wonder I can never see my hand when I'm playing poker at a circular table. I'm always at the edge of the table.
Alright, now I'm going to send you this, what I was going to send you originally.
Okay.
Alright, I sent the first one. And then I have a couple more to send you here.
Actually, we've only got 10 minutes left, so this one will probably use up the time we've got for this session.
And then for that sheet, we're doing just the bottom four. 17 through 20. And then just set the second one whenever we're ready.
Okay, so if they give us one solution to this polynomial, we're supposed to find all solutions?
Yes, a root of the equation is given, solve the
Yeah,
equation.
solve the equation. Okay, so what's our one solution? X equals minus 3.
Yeah.
So what am I going to do?
I believe you're going to set it up like you do division synthesis.
Yeah, synthetic division.
Yeah.
Now, it's also true, notice this happens to be a rather unusual cubic that you can group. If we didn't have one solution, we'd be able to come up with it pretty easily. This is not a hard cubic to solve. You see why I can group it?
No.
The ratio of the coefficient 1 to 3 is the same as 3 to 9. So that would allow me to group it. But they gave us one solution, so I don't need to do it that way. So let's synthetically divide. What goes in the box?
So what are we dividing by on these problems?
The answer.
So it is -3 in the box?
Yes, always. In other words, what goes in the box is the 0, not the factor. In other words, the linear factor is x plus 3. But what goes in the box is the solution.
Okay. So drag the 1 down, then you get -3, 0, 0, -3, 9, 0.
So my one factor, I'll write it like this. There's my first factor that I knew already. What's my other one?
Oh wait, hold on, sorry.
Based on those three numbers right there. That is your quotient. When you divide a polynomial by another factor, what you get is shown with below the line. So what is this?
X squared, 6x?
No, the 0 is the x term, so it's 0x minus 3. See how I got that from the 1, 0, minus 3?
Yeah.
Okay. Now that's not fully factored. In other words, we haven't solved it yet. If all that's equal to 0, what's the next step?
You have to find all the x's, so it'd be x equals -3.
Okay, that was the one we knew.
And then the other one is x equals, what number? I don't even know what number that would be.
Well, first of all, x equals what? Plus or minus?
Yeah, plus or minus
Root 3. You don't need to convert it to a number. You don't want to.
Okay.
Okay, so your three answers are x equal minus 3, x equal plus root 3, and x equal minus root 3.
Okay.
Okay, you good with that one?
Yeah.
All right, let's look at 18. Let's do the same thing. What are my numbers across the top?
Hold on. Alright. 18, it'd be 2, 9, 7, and negative 6.
Number in the box.
Hold on. Sorry, I was finishing writing this. The number in the box is negative 2. Drag the 2 down, you get negative 4, 5, negative 10, negative 3, 6, 0.
So my remaining quadratic is,
X plus 2, and then
oh, excuse me. Yeah, sorry.
and then 2x squared plus 5x minus 3.
Okay, now factor that.
You get x equals negative 2, and then is that? Oh yeah, yeah it does actually.
Okay, what is it?
It's 2x minus 6, and then x plus 1.
Okay, remember your numbers have to always multiply to this constant. So it can't be 6 and 1. It's 1 and 3.
Okay.
That produces the middle term of 5x.
Oh yeah, it does.
Okay. So what are my three solutions?
X equals negative 2. X equals 0.5. Then x equals negative 3.
Yeah. In general, if you're going to use fraction, well, you can use 0.5. No difference. In general, I would not mix up fractions and decimals. In other words, if I had one solution was 1/2 and I had another solution as 0.4, I wouldn't give it like that. I would give 1/2 and 2/5. Or I would give 0.5 and 0.4. Understand what I'm saying? Yeah, that's just a minor thing. I don't think your teacher would mark off for it, but consistency is valuable.
Do
All
you
right,
have a session after this? Do we have time for one more?
We don't actually. I do have a session at 8.
Okay.
So let's leave off at 18 and pick up at 19 when tomorrow is our next session.
I don't even know.
Hold on, let me pull it up here.
I don't think I'll need a session tomorrow if we do have one, because I have my quiz tomorrow.
Yeah, I'm pretty sure you have one scheduled. What is today? Tuesday?
Yeah.
You don't have one tomorrow. When's your quiz?
Tomorrow.
You don't need a session tomorrow, do you?
No.
Okay, good, because I don't have a lot of space.
Yeah.
I got a lot of time on Thursday and Friday, but you're also scheduled for an hour on Saturday, Sunday, and I think the following Monday. So you've got, no, just Saturday, Sunday, the following Tuesday, and that's all. Your mom wanted one on Monday, and I told her I could squeeze you in if it was an emergency. I got a couple of 20-minute spots there that we could combine if necessary. But with an hour on Saturday and an hour on Sunday and an hour on Tuesday, I think you'll be all right. If not, let me know, and we can certainly fit you in.
Yeah, I think I'll be fine.
All right. I will talk to you Saturday at noon.
All right.
Okay, Jackson. Have a good week.
All right. Bye.